Good morning to everyone in the audience, at least if you're in the United States, or in Europe, good afternoon. My name is Robert McLean. I'm the publisher of The Prime, based in Prague, covering the Czech and Slovak property markets. We're here to present a webinar on digital twins. Now, that topic was covered in Acular's last webinar, but just in case there's anyone who's new to the concept, think of it as the virtual version of an actual object. A digital twin provides a virtual representation of an actual object, but it's not just a 3D picture of this object. Instead, it's a way of representing the object and the systems that govern its functioning in real time. Over the next 29 minutes, we're going to look very specifically at how Acular has teamed up with Schnabel Engineering, Synthetics, and EO59 to bring the design and operating of critical infrastructure projects into the future. Now, here we're talking about everything from runways to hydroelectric dams to factories. These are massively expensive and complex structures. They have to be designed with incredible attention to detail. But building is just the beginning of the story. Once they're operational, they have to be maintained with a high degree of precision over a period of years or even decades. There also have to be contingency plans in place in case of emergency, meaning that any potential type of catastrophic event has to be accounted for. First responders need to have all possible information about the structure available, and they need to be able to understand and visualize that information with as much context as possible. That's exactly why the functionality that this alliance of innovative companies that we've got collected for you here today on this webinar is developing. They'll be explaining what they've achieved so far and what's still being developed. I thought it might be useful to begin by explaining how companies currently look after and maintain critical infrastructure. Then we'll get into explaining how augmented reality can be leveraged to present this information through a single application, on location, in context. So to get things rolling, let's start with Alan Cadden, who joins us from Philadelphia. Alan is a principal at Schnabel Engineering. Alan, could you give people a brief description of Schnabel's core business, and especially how you're involved in the operation and maintenance of critical infrastructure?
Thanks, Robert. Yeah, just a little bit of background. Schnabel Engineering has been around about 65 years, and we started as a more traditional geotechnical engineering firm, but over the last several decades have really grown to have a strong focus on infrastructure, whether that's roadways, highways, bridges, tunnels, or dams. A lot of our work these days is focused on dams, and that design can be from a basic rehab to a completely new structure. So the development of designs for these infrastructure systems can get pretty complicated and often involve quite a few different team members. So coordinating with different team members, sharing information, producing documents, even across our own company with many offices working on these projects, has gotten more complicated and more challenging. It's also gotten quicker. One of the main things that we find that's kind of interesting and an exciting challenge is how do we help our clients? The term we like to use is cognition. These designs can get very complicated, a lot of data feeding into them, and helping them understand and visualize what we're proposing, what some of the decision points are, is challenging, and the advanced visualization tools seem to be helping with that explanation. Part of this effort has been to expand a lot of our what we call infrastructure monitoring services, or instrumentation data streams. So more than just capturing data, how do we then feed that data back into these models to help make the systems very understandable? So that's where we fit into this puzzle, I believe, and looking forward to working together with this team.
Maybe you could give a few, thanks, Alan. Maybe you could give a few examples of the type of, maybe just pick one of the types of infrastructure that you work with, and what sort of information are you monitoring that helps people understand what shape that facility is at the moment?
Sure, I think Martin might be showing an example a little later, but the Jaeger Airport was a real challenging project where they had a 300-foot high landslide at the end of the runway. And our job over several years was to clean that mess up and stabilize the hillside and rebuild the runway. And that required basically an 8-story building to get built at the end of the runway. So it was an 85-foot high retaining wall, complicated reinforcement and installation in a tight environment. And the instrumentation we installed throughout that project allowed us to verify the numerical modeling of the design with the construction processes. And now we continue to monitor deformation and stresses within the structure itself for long-term performance asset management of the site, as well as we're using INSAR to monitor the wall and the surrounding areas. Since the airport's built on top of a mountain, it's important to keep an eye on everything, not just this one wall.
Maybe you could give. I mean, that INSAR is quite fascinating, but it's possible not everybody in the audience is going to know what that is. Explain what that. I mean, that's where you're working with the company EO59, and they're if I understand it correctly, they're providing basically incredibly precise satellite radar positioning. How specifically do you use that, and how does that, and who needs? I mean, who really needs to know the location of this huge piece of infrastructure that's probably not going anywhere?
Well, we hope it doesn't go anywhere, but when you're at the top of a mountain in West Virginia, things tend to slide and move around quite regularly. So yeah, EO59 has been a great partner, and we've been working with them for years now. And just being able to use satellite radar systems, the synthetic aperture radar, to basically every day or on a regular daily cycle, the satellites pass over the Earth, every point on the Earth, and they capture data. And EO59 takes that data stream that comes from the European Union, as well as other satellite systems, and create stacks of this data. And once they build up enough stacks, they're able to track movement to millimeter type accuracy over the entire site. So if they can get a good reflection off the ground or off a structure that's repeatable, they're able to monitor that point long term and tell us whether something's moving. So
and going back in time as well, isn't that the case, that you can go back in time on this?
Yeah, we've actually used them quite a few times to look at kind of a historic retrospective of why did something start moving or when did it start moving. So these satellites have been up since 2016, and they can go back and look at all that data. And it's really the only instrumentation that you can think of that's able to look back in time.
Okay. Now, moving on, maybe we could bring Tim Brewer into the discussion from Synthetic Technologies. Tim, the main purpose of real-time monitoring, obviously, is to prevent accidents. But even with critical infrastructure, things can go wrong. Anything from collapses to explosions or any other type of major malfunction. Tim, very broadly speaking, am I correct in saying that by using highly sophisticated modeling techniques, you're able to help stakeholders understand what could or what is likely to happen in a range of catastrophic scenarios? I mean, how did you come to understand the need for this type of analysis and to set up a company that could actually provide it?
Thanks, Robert. Yeah, no, that's a great introduction. I think a very fair assessment. I think broadly speaking, we're in the business of risk mitigation, sort of definition, quantification, both like before, during, and then after a potential incident. And as you mentioned there are a broad range and diverse range of stakeholders. Certainly the users of the infrastructure owners, the operators, the engineers, the insurers, and even indeed the first responders who are going to be the first on-site dealing with that particular scenario. Synthetic as a company are in the business of developing and running advanced computational modeling to trying to better quantify that risk and then provide mitigating measures. And we really need access to accurate geometric data, live sensor data, so live information from the infrastructure itself, and then the ability to visualize our results and communicate them to people who may not be computational modelers or may not even be sort of advanced engineers. And that is how we're leveraging the digital twin. And that's why we're so excited about this collaboration moving forward.
Okay. How do you actually go about getting this type of modeling information to so that you can, I mean, if you can convince insurance guys that what you're talking about is accurate, you're really, I mean, there's a high degree of probability that you're correct. But how do you like test that? I mean, does it mean that you literally get to blow stuff up?
Yeah, we do have the happy task of testing and validating the models that we've developed across a number of different sort of types of scenario, especially related to critical infrastructure. And in the United States, the federal government has a big hand in providing and funding those tests to make sure the infrastructure we have is safe and fit for purpose. And the same is true in Europe and the rest of the world.
Mm-hmm, mm-hmm. Okay. Martin Rappos is the CEO of Acular. Martin, how does augmented reality fit into all of this? I mean, we'll get on a little bit later. I think we'll get to how you actually do it. But the companies that we've been talking to so far in this webinar, they're doing the actual monitoring. Can you explain what Acular's role is in this process? Are you at the beginning of it, at the end of it, or are you on both sides of things?
Thank you for that. Yeah, no, you're right. So we're both at the beginning and the end, or let's say in the background, because while Alan and Tim work on getting and interpreting the data, we are then visualizing the data in the context and in the field, and it's either through augmented reality, so AR, or mixed reality, MR or VR. Or actually just on a 3D model where you have virtual sensors, we have virtual data endpoints that you can see in the context of the 3D model. So we're helping with the as Alan said earlier, the cognition, right? So we help to interpret and to show which data point we're actually talking about. You can immediately see what the implications are, or you can feel and understand what the implications are of that particular data point changing. But how we work with Tim, for instance, on a number of projects, is that we provide the 3D geometry of assets, where then Tim's team can run computational analysis, and as a result, then the visualization of the computation is overlaid on the original 3D model. So I think it's a great partnership, and actually helping, because Ocular is not only visualization, AR, VR, but it's also a digitization platform. So we very often create 3D models and create digital twins out of very, let's say, rudimentary inputs, where we just get 2D drawings or DWGs or just layouts. And so we create the basic 3D model, and then, for instance, Tim and his company, his team is doing the analysis on that, and then sends us the result back, where we can show it in the context. Unfortunately, a lot of the stuff that we work on together is confidential, so we will need to work on finding the right examples that we can actually show, which would be more in the civil and let's say private space. So yeah.
That's fascinating. Maybe you could just talk about the process of creating just the basic, the backbone of this whole thing, which is a visualization of a particular structure. I mean, how does that happen? I know with virtual reality, they're massively complex renderings that can take hours, or I don't know, days and thousands of dollars to create. What is it? What is it that Acular is doing? How do you handle this with augmented reality?
Well, we simplify the entire process. So with the BIM industry, which has been around for a couple of decades now, the actual strategy typically is to create a more and more complex 3D model and representation of what you are building. But for many operational use cases, you don't need the whole complexity. So what we're doing is we are creating simplified and easy to use BIM models, which then are either used for the computational analysis by Tim or for cognition and data interpretation by Alan. And for instance, when you mentioned augmented reality, so specifically with EO59, that's a company that will join us at the next webinar, and their satellite data, we've been able to put those satellite data into the context of the actual building, and then you go look at the building. That serves as your trigger and your anchor, and then you can see the satellite data points on the building, which is very cool for the people that aren't able to interpret it in any better way.
Right. Okay. And how long does it take to create it? You feed the information in, and how long until it comes out of your server, out of your machine?
Well, it depends. So we have multiple algorithms on our cloud, and it really depends on the input. As I mentioned, it ranges from really basic inputs where we need to put in some manual work as well, all the way to more sophisticated 3D inputs, which are quicker and automated. So it can range from 1 hour to let's say a couple of weeks, where we actually have processes of manual and automated and semi-automated workflows, which then create the digital twin.
Alan, I mean, the stuff that Martin is working on it's quite cool, and there's a big wow factor. But that's not why you're getting involved in this. I mean, it's a bit of a cliche to say a picture is worth 1,000 words. But what is actually the value that this brings? First, in terms of the speed and expense. But why do you find this is such an exciting way of displaying and conveying the information via this AR model?
Yeah, I mean, I think there's different needs for different projects. When we start early on a project and we're building out a design model and doing all the analysis in the background, building out a very robust, detailed digital twin goes along with the project development. But quite often we're looking more at an asset that's existing, that may be older, and being able to build out a relatively straightforward digital twin that's accurate, that we can apply modeling and we apply instrumentation, we can connect other data to, rather than being that fully robust design model. They're able to provide us the ability to generate a tool quickly and easily that we can help our clients understand all the data related to the site. So basically taking it out of the archives and the old file cabinets or somebody's laptop or desktop, put it all together, validate it, make it easy to understand, and then make it readily available to their staff, whether it's the old timer that's been there 30 years or the guy that just started yesterday. They can pick this thing up and have ready access to all the data. And in case of an emergency response, so can the responders.
So essentially, this is something like an application that's designed for a specific piece of critical infrastructure that collects all the information. So when you're talking about the digitization of these companies, it's not just these pictures, but they're going to have access to actual documents that have been scattered, as you're saying, in different places. Is that right?
Yeah, it could be historic design and construction documents. It could be equipment manuals and maintenance records. It could be, whatever they might have, an emergency response plan. You could have traffic flow, that's ongoing in the area that gets presented in this kind of a model.
Okay.
So yeah, it could be any data. It could start small and it can build as your needs grow. So if you want to start by looking at one piece of your project and build that out because that's critical today, then you can keep adding pieces to it and growing it until it takes, provides you the tool for your entire asset system.
Okay. All right. Tim, how can this sort of modeling that you're capable of providing combine with AR and and a series of robust monitoring devices to help first responders in the event of a catastrophic event?
Yeah, that's a great question. It really builds on what Alan was saying in terms of data availability, like data integration, and then data accessibility. these incidents are of course complex events with people coming to the infrastructure asset with no real understanding of, I guess, what they're going into, and then different agencies that need to coordinate. So I think really it's focused on giving them a better understanding and that kind of holistic picture of what's going on. And then in terms of data availability and things that we can layer onto the digital twin, we can use things like Blue Force tracking, or we can do things like integrated radio networks to allow people, once they arrive, to coordinate very effectively and very quickly so that people can go on doing what first responders are there to do, which is save lives. So I think that's kind of the value of digital twin and how that data can be integrated into a single platform.
And are there ways that working with Ocular and with the other companies, that are you involved in sort of the preparation? Because I think there's a lot of I think like civic centers, there's a lot of different pieces of infrastructure will have emergency plans. But does this enhance somehow your ability to help first responders have specific plans in place?
Yeah, I think, and more than that, I think legacy emergency plans used to sit on, used to be in a document, it'd sit on a shelf, and you get it out and review it once a year. So I think now it brings that emergency plan to life. It feeds in real-time data, dynamic data, and really allows it to be effective and usable rather than what we've had in years gone by.
Okay. And I mean, and this is a question for any of you, but I mean, I think part of this is playing a big role. I think even with insurance policies, is that right? Is this something are you getting responses from actual insurers that yes, this is a positive measure, and can it actually make a difference in the bottom lines of any of your clients? I don't know if Alan, that's a better question for you, Tim, or if it's for Martin, but feel free to jump in on that one.
Yeah, I'll maybe jump in and take an initial shot. I think from an insurance perspective, it's in everybody's best interest to understand the risks that are present and might particularly affect a typical piece of infrastructure. So I think the ability to understand that, to quantify it, and then to design suitable risk mitigation is a great thing for sort of life safety primarily. But then, of course, the financial underpinnings of that, how do we protect it from a risk perspective? Again, it helps the insurer out because he wants to understand the volatility in his portfolio, but it also helps the operator out because it's reducing the premium costs associated with it. So I think, again, this data availability and integration is helping all out, both from a life safety point of view and a financial point of view.
Okay. I would say even early on, a lot of our work, whether it's the tunnels or dams, or now we start to even look at it in rockfall stability on highways and such, but having data compiled and easily accessible helps us with either the asset management assessment, or how you schedule and maintain facilities and decide which is the most critical place to invest your maintenance dollars, or a risk assessment. What's the potential failure modes that might occur in a structure, whether it's a dam or a tunnel, and how do you start getting the data available so that the key people can truly understand it quickly and efficiently and make those kind of evaluations.
Okay. Alan, I was wondering, I mean, how does working in an alliance with these guys make your original technology more valuable? I mean, I get the feeling from all of you, and it's a question for all of you, I suppose, that putting you all together sort of in this alliance creates something that's greater than the sum of the individual parts.
Yeah, I've been with Schnabel for 35 years, and it's been interesting to kind of watch as new ideas and new directions emerge. Quite often we try to build these tools out ourselves, and we spend a whole lot of time kind of going in circles and not really getting to the end goal that you want to. So I think in the last many years, it's been more exciting to me to team with good partners that can help bring the tools together, and they can leverage their expertise. I can bring my skill sets to the team, and we can start putting together good products quickly and efficiently and bring them to market, rather than spending a lot of time in kind of a slow development with one project at a time.
Martin,
yeah, very much so. And I must say, I've it was great pleasure to start working with Schnabel and the breadth of knowledge that the companies gathered over the decades, on different projects and the specifics of projects, especially critical infrastructure. And we are very proud to be able to help with visualizing some of that. So our part is small, but it's the one that you actually see at the end of the day. So that's quite encouraging. And as Tim said, I mean, if you ranging from operational benefits where you are able to gather and to get your hands on all of the information that you need quickly, all the way to being able to locate people in an emergency, and bring down the time to rescue. So first responders being able to actually view a 3D model of an asset, rather than trying to get navigated over the phone. Or trying to figure out what's going on when they arrive on site, so they get 3-4 minutes before arriving. So, public safety, safety of workers on site can be improved with this. So, I think that's a great use of our capabilities.
I would like to say that there's to the guests or people watching this, you can send in a question or two. We're getting close to the end of the day, but Martin, so just put that in the chat. If you're interested in having any of the guys here answer questions. Tim, just following on from what Martin was saying, I was wondering if you think this type of technology could become mandatory on new infrastructure projects. Is that where you see this going?
Yes, I do. I can see, obviously more interest, and this webinar is an example of that. But certainly, I can see it becoming desirable just for all of the benefits and advantages that we've described during this webinar. But I can certainly see, both on the federal side and on the private and commercial side, I can see this becoming mandatory, both in terms of new, so design and construction, but then also moving from construction into operation. And I think, it should, because of, again, all the benefits that we've described during this webinar.
Okay.
I think the other thing that we're really kind of at a turning point in our industry is the instrumentation and the tools that are available, and the communication that's so robust now makes putting devices and sensors in structures so much easier, so much more reliable. And I think that's becoming an expectation from the asset management and response perspective. We see it on TV all the time. It's finally here in reality now.
Yeah, it does. It feels like a Tom Cruise movie in some way, with the guy in the van watching every single move that happens. We did have one question, which is that live sensory data and 3D geometric data from the BIM model, they're there for all types of purposes. But is there anything like the assessed information model for the development of digital twin?
Yeah, that's a great question. Quite often we work with complex asset models, asset information models, when you would have your design data in one silo, and your more or different silos from different vendors. You need to put that together, and then you have after that, of course, you have the operational data. And so you work with a number of complex data sources and databases to get all of the information from different 3D models, elements of the 3D models, metadata of that. So for instance, we work with the petrochemical industry, which would have number of vendors providing different portions of the infrastructure, and then that gets federated. And we need to use all of the information to create the digital twin.
Right.
Yeah.
Yeah, I think as we continue to compile all this asset data, we're going to start to see tools like machine learning start to dig deeper into that data and help us manage assets and anticipate problems more efficiently than we do now.
I mean, maybe just a final point that you guys, how long have you actually been working together? Because I mean, it feels very, very fresh and raw what you guys are talking about. I would expect, like most applications, that like I don't know if the sky's the limits, but we're really in the infancy of what's going to happen eventually, aren't we?
Yeah, I would think so. We started working with Martin, 2 years ago or something, when we were finishing up the Jaeger project and working on a hackathon, trying to find solutions for the pandemic, and it's just continuing to grow from that. So yeah, I'd say we're in the infancy, and there's no telling where we're going next.
Okay.
Yep. And Tim and I are working on a government project for almost, is it half a year now? Almost a year now.
Well,
yeah, so definitely, and that's bringing that knowledge from public safety and government funded projects and into commercialization. So we're basically bridging those two worlds in this consortium.
Well, it definitely sounds like it's becoming mainstream and potentially part of standard regulations, which means that it looks like it's going to be going big. I think we may have one more question. I'm going to see if I can find it. Okay, so thank you, Mohammed. Are there any issues of data interoperability with Ocular when it creates a federated model for a building digital twin with a lot of data, especially from a sustainability perspective? Martin, you going to take that on? Or any of the others, I suppose.
Thank you. That's a very interesting question from the sustainability perspective, especially, right? So yeah, no, we are very open. The digital twins that we create, they're not locked into our platform. So there are no interoperability issues. We're actually breaking all the silos, and we're trying to create a very open model where anybody can tap onto the data. And if you would like to expand on the sustainability perspective, I'd be happy to discuss that.
I think that's an excellent question. It's been one of my focuses for the last several years, looking at some open schema models for data, that we have to be thinking along the lines of being able to move data around to the new tools as they emerge. So it's exciting to see the trends in the industry focusing on open data.
Okay.
Yep. I know we need to try to keep this short and sweet. For the end, I was thinking maybe I just show a couple of examples.
Go for it.
So that one picture would be worth more than 1,000 words, and maybe that would be the case. So I'd like to show a little bit of the 3D model of the Jaeger Airport that Alan mentioned, and also I'd like to show what we did with Tim as an demonstration of an impact of an explosion. So Tim, while I bring it up, maybe you can give a little bit of an intro of the blast foam.
Sure. So again, building on the point of open data. So again, like Alan and Martin, all the codes that we build are free and open source, so available to the public, which allows, I guess, it builds confidence in them because we have a user community that can validate them, but then also allows them to be applied on different types of infrastructure projects. So working with Martin and his team, the geometry side that we need to that's a starting point for our modeling. His team is able to build that in great detail, but also in a format and a way that's suitable for the modeling that we're going to do later on. We then take that modeling on, conduct our analysis using the computational tools that we have, and then we're able to provide back the results to Martin in a format that he can visualize and within his platform. So I think that kind of is a great example of that kind of integrated approach that all on the team here are benefiting from.
Yep. So I'll play this. This is right outside your office in Austin, right?
Yeah, this is the Hilton Hotel in Austin, Texas. There are other hotels that are available. So yeah, this just shows the effect of a 2-ton vehicle-borne explosive device on the street outside that hotel there. So you can see, before we would be able to visualize the effects of this, perhaps on a map or some other format, but you can see the power of seeing that not only with the subject building there, but in the context of the wider city. And certainly from a first responder perspective, not only the building that's affected, the target building itself, but what might be the implications on the surrounding infrastructure in terms of executing a rescue are really important. So it's a great example.
And here, just a quick sneak peek into the complexity of the runway of the Jaeger Airport, which Alan was talking about earlier.
Yeah, so if there was a challenge out here, understanding the anchors holding the wall together, the importance of those elements, the foam blocks that are underneath the runway structure and the impact of that. And, even if you combine this with the actual topo of the site, just the access roads to get there for an emergency response would be critical pieces of information that could save lives.
Yeah. I just realized I'm not able to stream live in this platform from my tablet, so I needed to create a quick video that I'm playing here. But for next time, we'll figure out how to create a live stream and show some of the other projects.
All right.
Great. Okay. I don't think we have any other questions at this point. If Alan or Martin or Tim, if you have any other points you need to make, I think we should probably leave it there since we promised folks about a half an hour. I'd like to thank you all for gathering for this half hour. It's been fascinating. I learned something just as I do every time I talk to you guys. Been a real pleasure. So thank you very much, and for everybody in the audience. I think it was a fascinating for everybody.
Sounds good. Thanks.
Okay.
Very much.